So this last one in the final question of the final part of the final question of 2011 paper, Scholarship Physics, we have to calculate the final velocities of the pucks when they are a long distance apart. So it seems to me that energy is the way forward for this. We know the initial total energy from the first one. That should be the kinetic energies of the two EK of the red puck plus the kinetic energy of the blue puck. And that we know everything in this except for, in fact let's write it out, we'll write it out in full. So we know half times 0.002 times 21 squared equals half times 0.002 times what do we get the final velocity? Oh, we don't know the final, of course. Tricky. VR, we'll just call it VR final, VRF squared, plus the half times 0.004 times VB final squared. So we've got this full equation. We've got two unknowns in the whole thing, which is VR final and VB final, which is what we're trying to find out. Okay, and just because it's nicer, I'm going to do a bit of cancelling. We can cancel out the halves, and where's the other half over here? Oops. And we can also cancel out the 0.002, but in this case, because we're dividing by 0.002, this one's going to become 2. So we're going to end up with an equation that looks like this. It'll be 21 squared equals VRF squared plus 2VBF squared. We could reduce that down a little bit more if we really wanted to. So that's one equation. We can also look at the momentum equations, and we'll do so down here. So momentum, the initial momentum of the red puck equals the final momentum of the red puck plus the final momentum of the blue puck. And same thing in this, we know everything because we know the initial mass 0.002 times by 21 is the initial momentum, and that equals 0.002 times by the final velocity of the red final plus that's what I'm on, plus 0.004 times by the the blue puck final velocity. Okay, and again we can do a wee bit of cancelling just to make it look a bit tidier. We can get rid of 0.002 again, and this one will again become 2. So we end up with 21 equals VRF plus 2VRB. Okay, so that's nice. We've got two equations, and in those two equations we've got two unknowns, VRF and VRB. And all you have to do now is solve them simultaneously by substituting one into the other and rearranging and going through the whole process. So I'll start that off, but I'm not going to finish it. I'm going to rearrange equation 2 here to be VRF equals 21 minus 2 VRB. Where do I get VR from? That's meant to be VBF. There we go. V blue final, the same as it is up here. So now this value for VRF, I can substitute it in to, that's VRF, so yeah, so substitute that into here and square the whole lot. So that's that bit down there. Or if I wanted, I could square it first and then rearrange it. So I substitute those values and rearrange, and works out, I think, that VRF was about 7 meters per second and VBF was around about 14 meters per second, I think. which is what you'd expect based on the masses and the proportions of the masses and velocities and all that kind of stuff. Very cool.